Students, now we discuss the next concept, regression. Now, before taking the definition of the regression, we take the definition of scatter diagram or dot diagram. With the help of this definition, we define what is a regression. Okay, then what is a scatter diagram? To obtain a measure of relationship between the two variables, we plot their corresponding values on the graph, taking one of the variable along the x-axis and the other along the y-axis. The resulting diagram showing a collection of dots is called scatter diagram. So already you know that. So usually in the physics lab or chemistry lab, when you take the uh, readings, okay, we usually draw the um, by taking the data. Okay, suppose this is the x-axis and y-axis. Taking x value and y value, we get one point. Okay, then taking the another x and y value, likewise taking the values of x and y in a xy plane, we get many points in the plane. Okay, along x-axis and y-axis, we take the values of x and y, we are getting the many points in the plane. Okay, and this collection of points or the collection of these dots are called the scatter diagram or dot diagram. Okay, now the next what, after taking the points in a plane, we are going to join those. Okay, we join the all the points, then we get one curve. Okay, now we define the regression. If the scatter diagram indicates some relationship between the two variables x and y, yes, yes, definitely, because when you're taking the point in a plane, that represents the relationship between x and y. Okay, then the dots of the scatter diagram will be concentrated around a curve, means when you join all the points, we get a curve. Okay, and this curve is called the curve of regression. Okay, so that is what I shown here. When you join the points, we get a curve, then that curve is called the curve of regression. So regression analysis is the method used for estimating the unknown values of one variable corresponding to the known value of another variable. Means when you take the when you join the all the points, we get a curve. Okay, suppose that curve may be, it may be a straight line or it may be any curve. For example, if you take that curve may be y equal to a plus bx. Okay, so this is the straight line we get from the scatter diagram. Now what we do, this regression helps to find the unknown value. For example, if this is the straight line, we can give some values for x, we get the some value for y. Okay, with the help of this regression, we can find the value of unknown with the help of known value. Okay, now the the next concept is we have the line of regression. Line of regression means in the scatter diagram, when you join the points, we get a straight line. That is what we call the line of regression. See, when the curve is a straight line in the scatter diagram, it is called line of regression. Okay, very simple. When you take the all the points in a plane and when we join, we get a straight line. That is called the line of regression. Yes, so here is that x-axis and y-axis. So there are many points we are taking. When you join the points, okay, the possible curve is y equal to a plus bx, or we can take in another form as x equal to a dash plus b dash y. Then what these straight lines are, we see here. Consider a line y equal to a plus bx. So this is the line which gives the best possible mean values of y. Which gives the mean values of y means for known values of x, we can substitute the value of x, we can get the values of y. Okay. So this is known as, this line y equal to a plus is known as, this point you remember, this is the line of regression of y on x. Okay, this point you remember. Whenever there is a straight line y equal to a plus bx, we say this as a line of regression of y on x. Similarly, the another line is x equal to a dash plus b dash y. So this is what, this gives best possible mean values of x for each specified values of y. This is known as the line of regression of x on y. So this point you remember, because in the problem the question will be asked as find the line of regression of y on x, means you have to get y equal to a plus bx. If the problem is find the regression line of x on y, then you have to get this equation. Okay, now so here is the formula to find line of regressions. Okay, so here this is the derivations, but the derivations is not there for in the syllabus. So directly we take the formula how to find the regression lines x on y or y on x. Okay, so here is the formula. Yes, so this is y minus y bar equal to r into sigma y by sigma x into x minus x bar. So this is the formula to find the regression line of y on x. Okay, remember that this is the regression line of y on x. Y minus y bar equal to r into sigma y by sigma x into x minus x bar. Okay, now so this is the another formula which gives x minus x bar equal to r into sigma x by sigma y into y minus y bar. So this is called regression line of x on y. Okay, so don't get confused with the x on y or y on x. So now, so this is the one important point, the coefficient of x in equation 3, the coefficient of x. So here the coefficient of x is r into sigma y by sigma x, and the coefficient of y in equation 4, y coefficient is r into sigma x by sigma y. These are known as regression coefficients. So these 2 points you remember, and don't get confused with sigma y sigma x and here sigma x by sigma y. So remember properly regression coefficients. So and these, and the product of these two gives r square, because when you take the product of these two, sigma y cancel and sigma x cancel, we get r into r square. Okay, this is the one important point. Now so this note will help you to write the formula in the simplified form, that is the line of regression of 3 and 4 are also of the form. So these forms are very simple to find the regression lines. So this is given by capital Y equal to summation summation of capital XY, this is the product, divided by summation x square, then this whole into capital X. So this gives the regression line of y on x, where capital Y is y minus y bar and capital X is x minus x bar, and this is what capital X equal to summation xy divided by summation y square into capital Y. So this is the regression line of x on y. Okay, so these are in a very simple form and it is very easy to remember also. So this form will be useful to find out regression line first before finding the coefficient of correlation. So this sentence is what usually in the problem the two questions will be asked. It just only concentrate when the values of the set of values of x and y will be given, there will be two questions. The one is we have to find out the coefficient of correlation R. Okay, so that we discussed in the previous video. R we have to find out, and also we have to find out in the same problem we have to find out the regression lines. Okay, so therefore, so here, if the two questions are in the same problem, first we have to find the regression lines with the help of these. Then it is very easy to find the value of R. No need to again taking any summations and all. See, the formula is very simple. R equal to plus or minus square root of coefficient of x. When you write the line of regression of y on x, from that we get the coefficient of x and the coefficient of y from the line of regression of x on y. Okay, taking these two coefficients and the square root of that gives the value of R, that is a coefficient of correlation. And remember, this is a very important. When we have plus or minus, if both the coefficient of x and coefficient of y are positive, this one is a positive and this is positive, then you take the value of R as a positive. This point you remember. If the coefficient of x is negative, coefficient of y is negative, if both are negative, then we take R equal to minus of this value. Okay, usually you say minus into this minus become plus. No, so as by the condition, if both are negative, we take the value of R as a negative. Okay, this point you please remember. Now, so here is the problem. See, in this problem two questions are there. The one is correlation coefficient, that is R, between x and y, and also we had to find the regression lines for this given data. So therefore, before finding the value of R, first we find the lines of regression, then we find the value of R using this formula. Yes, first so the suggestion is, before writing this formula, this form is a very simple to remember, but you write this as a y minus y bar, this is capital Y, then summation xy means x minus x bar into y minus y bar divided by summation x square as x minus x bar whole square, then this capital X is x minus x bar. You also write in this form. Okay, and then this is a line of regression of x on y, this is y on x. Then what all we need, we need capital X means we need a x bar, mean of x and mean of y. So we take small x and small y, the given values of x and y, then we form the capital X and capital Y values taking x minus x bar and capital Y is y minus y bar. Okay, then as by the formula, what all we need x square column, we need y square column, then we need x into y. So these are the summations we required in the formula. Okay, now finding the values. So here are the summations of these three. Now here we are not putting the values of the summations, we are not putting in this, we are putting here y minus y bar. Y minus y bar is 30.7 equal to summation xy. This we take as a summation xy. The value is 385.5 divided by summation x square 82.5, and now capital X, that is x minus x bar, we write in this form, x minus x bar is 5.5. Okay, so this we simplify and we try to put in the form of y equal to a plus bx. See, this we simplified, and it is in the form of y equal to a plus bx. Similarly, we take x minus x bar, this is summation xy, then divided by summation y square, then y minus y bar, then this we put in the form of x equal to a plus by. Okay, so we have to put in this form. So these are the regression, this is the regression line of y on x and this is x on y. Okay, very simple procedure. Now the second question is coefficient of correlation. How we find? The formula is r equal to square root of coefficient of x. The coefficient of x we get from the regression line y on x. Here is the coefficient of x, taking that which is positive, then the coefficient of y from the regression line of x on y, so that is 0.2. so when both are positive, we keep this r in terms of positive, which is 0.96. okay, so this is the one type of problem when the values of x and y are given. See, this is the another problem where x and y values are not given. So in this, regression lines are given. The two regression lines, the one is, this is x on y, this is y on x. Now the question is find means of x and mean of y. X bar and y bar we have to find, and also coefficient of correlation we have to find. X bar, y bar and r we have to find out. X bar and y bar, how we find? Since the mean of x and y lies on the two regression lines, so these regression lines we take x as a x bar and y as a y bar. Okay, then we solve these as a simultaneous equations. So this we write in the standard form as x bar plus 0.87 taken this side, this is y bar, equal to 19.13. Similarly, this equation we can write as y bar plus 0.50 x bar equal to 11.64. Writing in this form, we solve these as a simultaneous equations, then we get the values of x bar and y bar. Okay, so very simple, solving the simultaneous equations we get x bar and y bar, that is the mean of x and y. Then we can find very easily the value of r, that is square root of coefficient of x and the coefficient of y. Okay, so these are given in the problem. See, coefficient of x we take from the y on x. Here is the coefficient of x minus 0.5, coefficient of y from x on y minus 0.87. When both are negative, remember this one point, if both are negative, we take the value of r in terms of negative. This point you remember, clear? So this is again the similar problems. Okay, so where the regression lines are given, we are finding only x bar, y bar and r. Okay, this is one another problem, clear? And similarly, see in this problem, so here the lines of regressions are given, right? And the question is find the mean values of x and y, standard deviation of y and coefficient of correlation between x and y. Okay, the first question is x bar, y bar we have to find, and the second is sigma y we have to find, and the third is r. And here the one point you observe, 4x minus 5y plus 33 equal to 0, 20x minus 9y equal to 107. So from these it is somewhat confused to take which one as a line of regression of y on x and which one as a x on y. Okay, so this is a little bit confused because these are not given in the standard form. The standard form is, one is y equal to a plus bx, the other is x equal to a plus by. So these are not in those standard forms. So therefore the first one is a very simple. To find the mean values of x and y, we take x as x bar and y as y bar. Okay, we solve these simultaneous equations, we find the values of x bar and y bar. So that step is a very simple, x bar and y bar. Now what we have to do, rewriting the line of regression y on x. See what here in this problem we did, from the first equation we took the line of regression of y on x, then second equation we took as x on y. See, this is how, whenever we take the line of regression of y on x and x on y, okay, now these are in the standard form, y equal to a plus bx, this is x equal to a plus by. Now whether the way we took the first one as y on x, the second one as x on y, whether this procedure is correct or not, how we can verify that? We continue this, then we find the value of r first before finding sigma y, because to find the sigma y, that is standard deviation of y, we need value of r. Therefore we first find r value. So therefore r is given by square root of coefficient of x, then coefficient of y. Okay, then this we calculate. When both are positive, we take r equal to 0.6. Now the question is, why we took the first one as y on x, the second one as x on y? So here we cannot say directly. Suppose the value of r is lies between -1 and +1, then the way we took is correct. Suppose if you take the vice versa, then the value may lies outside the range -1 to +1. Suppose in case if it happens, if you take the vice versa, if the value of r lies outside the range is, it should lies between -1 and +1. If it lies outside that, then we have to interchange these equations. Okay, that point you please remember. Then how we find the standard deviation of y? So this is the formula. This is what? The regression coefficient of x. Okay, this point you remember. This is the regression coefficient of x. The regression coefficient of x is r into sigma y by sigma x. So the regression coefficient of x in this, we have 4 by 5. Or you can take the regression coefficient of y also. Either you take this or this. From any one you can get the standard deviation of y. I took the first one. Okay, then substituting r, and the standard deviation of x is given, which is 9. Then from this we get the standard deviation of y. Okay, so this is the another different problem. Okay, thank you.